Thank you for coming to our talk. We're here to talk about making workloads, not infrastructure. My name's Will Stewart. I'm the CEO and co-founder of Northflank, a self-service developer platform. We're a European-based startup.
And I'm Dinesh, CTO from Civo. We are a cloud provider and hosting the lovely conference that you're at today.
Thank you. It is a lovely conference and it's lovely food. So why are we here today and why are we in this room? In the last 10 years, we've adopted Kubernetes, we've deployed thousands of clusters, and it was all meant to make it super simple, right? Kubernetes is super simple. Ultimately, the complexity has continued to grow. The stress on engineering teams, DevOps teams, platform engineering teams, whatever we call it, platform engineering is a concept in the last 2 years. The complexity has continued to spiral. So is there another way? Can we think about deploying infrastructure through workloads rather than configuring a load of Helm and YAML charts? You're all infrastructure experts in the room. I hope you've muted your PagerDuties. I certainly this morning didn't. So a few pings went off. The first year of Kubernetes is almost super simple. You create a cluster, you're done, right? All you have to do is log into Civo or GKE and create a cluster. You've gone to production. Unfortunately, it's not that simple. When you deploy a cluster, you create it, well, then you actually have to ship some workloads to it. You have to get a microservice, some databases, you need to implement disaster recovery, then you need to do your first cluster upgrade. It goes wrong, you need to create new node pools. After 10 years of doing that, suddenly you've stepped on 1,000-foot brakes, and suddenly your engineering team is now 10 times bigger, and you're spending a ton of money. We all appreciate the value of better abstractions, which some of these logos here, Linux, DirectX, game developers now don't write polygons manually, they use DirectX. Enterprise software engineers don't write software from scratch, they use a framework called Spring Boot. And we don't write in the Linux kernel directly. We have higher level abstractions to complex problems. Now we put Kubernetes down here as well because yes, it's a higher level abstraction to infrastructure. It's helped pull together compute, but it hasn't simplified actually deploying software or applications to your cloud infrastructure. It's pulled it together, but it's not simplified it. Applications like Next.js and React you're also super familiar with, made front-end development super simple. And now we need to think, how do we make this sort of developer experience available to software, to infrastructure engineers and platform engineers? It's very difficult to find these right abstractions. For example, we speak to lots of infrastructure and engineering leaders across the world, and they all tell me that their self-service developer experience and golden path to production, they've been on this path for 5 years now, and for example, some of them have not even built a UI yet. They're still stuck in YAML charts, and they've spent many millions of dollars adopting Kubernetes and investing in it, and they're still not even past really the first stage. So you can liken any company at any reasonable scale as building a platform is like building a factory. They have to build the factory before they create the car. And that is ultimately what every platform engineering team is doing today, manually, and recreating the wheel. Some of the tools, Argo CD, Terraform, Helm, Kubernetes. There's too many tools, too much glue, too much work. But ultimately, what are we all trying to do here? We're all trying to write software, ship applications to production, generate revenue, get paid, and go to Civo Navigate for free swag. So let's look at a real-life example. And this is where we're going to have an enjoyable deployment of a Llama model on top of Civo. But first of all...
Well, thank you. Well, I wasn't brave enough to actually do another live demo today, and especially do Llama from scratch. So came up with at least an idea of the things we could think about of what would be required to get Llama up and running. So everyone's heard about it. Really cool tool that allows you to run private models. So first thing you need to go off and do is find a VM, find some hardware. Very easy in the cloud. But you then need to get some GPUs attached to that as well. So you now need to make sure that you're in the right cloud that has the right GPUs at the right cost point and availability. Then you need to go, well, this model, does it need to be on A100s, H100s, L40Ss, T30s, T40s? I am telling you real GPUs that you would have to go away and start investigating to see whether or not they're suitable for what you're wanting to do. So we think, fine, chosen the cloud provider, got a VM up and running. Next thing we need to do, NVIDIA drivers. Fine, we'll work our way through that, get that all up and running. Then we'll go on to Llama, then probably get Docker because it runs in a container. Then all of the other steps on top of that. So first thing that we'll go away and do is probably look at the documentation. So hands up if anyone has actually tried to do all of this from scratch on their own. Anyone looked through the NVIDIA documentation site and understood what it takes to do that in under 2 days? Right, and then trying to work through all of that, you've got an iteration cycle to go into that. Get the drivers on, probably find you've got the wrong version of the drivers for the card that you're using, realize that you can't uninstall without doing a full reboot of the node, and then it leaves something behind. And after half a day, you're provisioning a new VM, reinstalling the right version of the drivers as you think, and then getting the Docker container and the Docker shims ready to go into that one, realizing actually now the container D driver, it isn't compatible with your NVIDIA drivers. Guess what? You're back to square one, provisioning a new VM, getting the drivers, and getting the container shims up and running. And that was just for one of the components. Next, we go over to Llama. Pulled up the Llama page. No, there are no docs links on the home page for Llama. So you're then using some more time trying to find out where that is, working out how you get that integrated with Docker, and getting Llama pulled down. Next thing you want is a nice front end for Llama. I think they've renamed it recently to the Open Web UI. That's on now a GitHub page. So you now need to go into that one, understand what that is, try and dissect where the documentation is. There's a nice handy docs folder, but you can kind of see what we're doing here, of that every time you get to a new level in this level of abstraction, you've got a new tool, a new way of working out what you need to be doing just to get Llama up and running. It takes some time, but eventually you get there, right? Everything's done, everything's fine, you get everything running, and someone goes, great, that was awesome, I really loved it. The other team next door, they'd really like a version of this. Can you do it again? And it kind of just fills you with some real happiness inside. You're really excited about everything that you've done, and you're ready to just go down the whole rabbit hole again. And this is what building infrastructure can be like. But I think what we're trying to say here is that there's a better way, and that's building a repeatable system with a platform. And that's what the team at Northflank have been doing.
Awesome. Thank you for the walkthrough of doing it the hard way. So what we've prepared earlier, a Blue Peter joke, but for those in the UK, you'll get that. We have created a Civo cluster on the Northflank platform. It's got a couple of GPUs pre-provisioned, and we've created a template here, which creates this Civo cluster. I'll just show you the configuration. It's deployed in the London region. It's running 1.28. I think it's actually 1.27 Talus. And it's got 3 nodes with an NVIDIA L40S deployed. It's got 100 gigs of ephemeral storage, and it's in the default availability zone. We don't need to worry about the other configuration. And then we've created a project, which is a grouping of compute. It's a hierarchical grouping of compute, and like a project to a namespace. So this is a namespace running on the Civo cluster. And it's just targeting the cluster we've created. And then we've created an Llama deployment service, which is pulling from Llama latest from Docker Hub. It's got HTTP configured. It's got some compute memory configured. And then we move on to the other component, which is the Llama web service. Again, pulling from GHCR this time. Funny enough, they don't even offer their services through the same container registry. we've configured a public port running on port 80. We've got a public and private endpoint available. And again, we're running with 4 CPU and 8 gig of RAM. And this doesn't have a GPU attached, but the Llama service does. I'll just head back there. It's in the project configuration. I'll show that later. So what does this look like? So after running this template, we can come over to runs. We can see that this is run through, and we can see the state of the history of that run. We can see that the Civo cluster was spun up. It took about 3 to 5 minutes to spin up. Created a project, created 2 deployment services. They've now been deployed to the cluster. And now we've got a URL generated here from the project. And now we can start asking it some questions. What should we ask it? How to deploy?
We can probably ask it, yeah. How can we deploy LLM workloads or Llama?
Oh.
Model at the top, if you've.
As we can see here, that's again, it's not a simple thing. And what we've done is we've just deployed one workload. As an organization, you have to deploy hundreds, if not thousands of workloads. Some organizations we talk to have 1 million microservices. How are you meant to deploy and create a platform manually per service? You need high level abstractions to simplify this.
Absolutely. I think this is what we're trying to do now is this next level of platform engineering, right? We've had Linux admins, you've had DevOps engineers, platforms. There's this now next level abstraction because we've got so much complexity in all of the various ways of deployment that another level of abstraction is wanted so that developers can get back to coming to Civo Navigate and getting all of the free swag.
Is anyone in this room building a platform at their organization at the moment? Couple. Anyone looking at building a platform or trying to provide sort of a self-service developer experience to their teams? We've got more people talking about self-service. So building that self-service is building a platform. You can liken it to building a product for your internal engineering organization. And then you could call it product thinking, platform thinking, but we're all doing the same thing. We're just calling it different things. And you could also call it golden path to production. Staying on the golden path to production is also building a platform. You're trying to provide repeatable workflows to your engineers. And today we've deployed an Llama model, but tomorrow it's a different model. It's Claude, or it's something different every week. And the whole point is that we've templated it. An engineer can self-service come in here and change the model. They can change the GPU it's running on. They can change the cloud. Not in Civo's case, you have to use Civo. You can't leave the building.
But yeah, I think this is what we're trying to do as engineers, and this multi-cloud abstraction level where you can take it to AWS, you can take it to Google. Finding the right home for the workload is what we want to be doing as engineers to solve problems that are real-world problems and not kind of be locked in. The templating system that a platform gives you allows you to migrate that workload around, gives you the repeatability, and ultimately stops the pages coming through PagerDuty, and everyone is allowed to sleep, which I like sleep.
And of course, here we've deployed one environment. Suddenly your engineers are going to ask for a preview environment for multiple staging environments. I'm sure we've all been on organizations where there's a queue for staging. Well, what if you could eliminate that queue? Every single PR that an engineer creates a temporary environment, spins up Postgres, Redis, RabbitMQ, MongoDB, whatever stateful services you need, temporary spin up, spin down, and you can deploy production staging and preview environments using a consistent templating system so that you're not having to reinvent the wheel every time a new microservice is considered with an organization. You just say, Cool, we've got a template ready to go. Let's just modify it slightly, add in a new service, add in a new environment. Yes, staging and production are going to have different overrides. For example, staging is going to probably have less replicas, less resources. Everything else is virtually the same. So you're just providing overrides to these templates. And suddenly, things become much more simple, or at least in theory.
Brilliant. Well, thank you very much. I guess, are there any questions?
Cool.
Brilliant. Thank you very much. I think booth crawl next. So back in the sponsor hall downstairs, Will and the team from North Flank will be there if you wanted to see the platform in any further detail.
Thank you for coming and listening. Thank you.